Now, if we have a vector and we have its components, how can we find the length of that vector? So our plan would be to figure out, well, okay, how long is this vector? Let's say we have a vector in 2 dimensions. Maybe our vector is 3, 5. Then the length of u, or another word for length would be magnitude. Oops, extra d there. Magnitude of u, or we could say the norm of u, the measurement of u. Those are all words for the same thing. Well, if you want to calculate the length of this vector, you could put its tail at the origin and count that it goes over 3 and up 1, 2, 3, 4, 5. So by the Pythagorean theorem, if you go over 3 and up 5, then the length of the hypotenuse here is square root of 3 squared plus 5 squared. So we have the square root of 9 plus 25. Would be the square root of 34, the length of this vector u. Now, to avoid having to write one of these words, length or magnitude of norm, we'll just take the name of the vector and we'll put it inside. These look like absolute value braces, but since the name is bold, we know we're talking about a vector, so we're really talking about the length of that vector. So the length of u is 34. In general, if you have a vector in 2 dimensions, it'll have 2 components, and its length will be the sum of the square root of the sum of the squares of the components. So it's the consequence of the Pythagorean theorem. Alright, notice this little thing. Well, let's see. If your vector is in 3 dimensions, you'll have 3 entries. I'll call them v1, v2, and v3 for this particular vector whose name is v. Its length is going to be basically how far it can carry you from the origin, or the distance from. If you put its tail at the origin, then the head will be at the point v1, v2, v3. So the length is going to be v1, the square root of v1 squared plus v2 squared plus v3 squared to find the length of that vector. Something kind of cool about the length of the vector is that if you divide a vector by its length, then the length turns out to be, the length of that new vector is 1. So you think if we scale a vector by 1 over its length, then you get a vector of length 1. So a vector of length 1 we call a unit vector. So for example, we just said if you have a vector u that has 2 components, u1 and u2, then the length of u is going to be the square root of u1 squared plus u2 squared. If you take, since that's a single number, right? That's not a list of numbers, that's just a single number, it's a scalar. If the vector has any length at all, then this won't be 0, so you could take this 1 over that would be another scalar, 1 over the length of the vector would be a scalar, and multiply it by u, and you get this new vector, u1 over the square root of u1 squared plus u2 squared, and u2 over the square root of u1 squared plus u2 squared. Now the length of that, so the length of a vector divided by its length, let's see, that would be the length of this, right, which is this squared, which makes u1 squared over u1 squared plus u2 squared, and plus the second component squared would be u2 squared. If you square this square root, you get u1 squared plus u2 squared. And this is perfect. They have the same denominator, so we end up with u1 squared plus u2 squared over u1 squared plus u2 squared, which would be the square root of 1, which is 1. So if you take some vector and divide it by its length, what you get is a vector that points in the same direction as that vector, but it has length 1. Of course, you have to make sure that your vector doesn't consist of 2 zeros, otherwise you're dividing by 0. So, but if it consists of 2 zeros, your vector really doesn't go anywhere anyway. So if you have a non-zero vector and you divide it by its length, you're going to get a unit vector. This is kind of handy. Let's look at an example. Suppose we've got this vector v. I'll do it in 3 dimensions so you see how it works, but this vector v has got components 1, 2, and 3. And so the length of this vector would be the square root of 1 squared plus 2 squared plus 3 squared. Let's see, that's the square root of 1 plus 4 plus 9. That's the square root of 14. So we could make a unit vector that points in the same direction as the original vector v just by dividing each of the components by the length. So we're dividing everything by the square root of 14. The handy part about this is we have a vector. It points in the same direction as the original one, but it also has length 1. So we could then, once we have a vector that has length 1, we call that a direction. So sort of a direction with sort of unit magnitude. So we just think of it as, this just gives us the general direction, and then it's easy to scale it. So once we know the direction we're going, if someone said, I want you to go 7, I want you to go a distance of 7 in the direction of v, first you could make the direction, make the unit vector that points in the same direction as v, and then multiply it by 7. So 7 times v over norm v would be the scalar 7 times this vector. That would give us the vector 7 times 1 over root 14. 7 times 2 is 14 over root 14, and 21 over root 14. Well, that could be simplified. In particular, we could rationalize the denominators. But now we have a vector that points in the same direction as v, but it has a particular length, of length 7.